Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job building Windows and web apps for some of the world's best companies as quickly as possible. So in this lesson, we're going to look at collections, which are more full-featured arrays. I'm also going to talk about object and collection initializers, which allow you to initialize the properties of a new object or initialize the properties of multiple new objects in a new collection in just one line of code. And it's a very cool feature. It saves you a lot of typing. We'll come back to that in just a moment. So previously, we looked at arrays. And at the time, I said that an array is simply a sequence of data. I said a collection of data, but I didn't like that term. It's going to conflict with what collections really are. But it's a grouping, a collection, a sequence of data that's stored in the computer's memory. And you can access any individual element of that array by using its index, which is just its ordinal position inside of that data structure. Okay, so arrays are great. However, they lack a couple of important features. For example, the length of arrays are fixed once you declare them. So what if you need to add more items to the array, or what if you need to remove an item from the array? You can't do that, all right? Or what if I wanted to use some other technique to retrieve an item from this array? What if I wanted to, instead of using its ordinal position, I wanted to use some sort of a key to get at an individual item? In other words, what if I were working with customer data and I wanted to look up a specific customer by their last name or their customer ID or some other key that I've defined? Well, can't do that either, all right? So that's where collections come into play. So what I want to do, I've already created a project that will allow us to see what collections can do and what some of their limitations are. And so what you want to do is download the zip file that's associated with this project. Now it'll either be where you're currently streaming this video from or wherever you originally downloaded the video from. There should be a link to some source code files. All right. So the source code file for this project, I've already unzipped it and I put it into my documents directory. And inside of that, you'll see there's a before and after folder. We want to use the before folder because it kind of gives us the setup that we're going to use for the rest of this lesson. And so there's a working with collections project. I'm going to right click it and select copy. And now I want to go to my documents directory, and I'm going to this time go into the Visual Studio 2013 folder, and I want to paste this into the projects folder. So I'm just going to select it, right click it, and select paste. And if it goes well, then I should be able to find working with collections then in my projects folder. I'll double click the solution file inside of that folder, so the .sln, or you'll see the file type Microsoft Visual Studio Solution. I'll double click that and we'll open it up in Visual Studio. So another technique that you can use to load code, a project or a solution from your hard drive. Okay, so as you can see, inside of this project, I have a simple car that I've created and a book class that I've created. And both of these classes support just a couple of public string properties. Great. And then in the static void main, I create instances of those new classes. So a car1 and a car2. And I set its properties, and then I also create a new instance of a book called a B1. All right, and so what I want to do is add each of these items into a collection. We'll do that in just a moment. Okay, so I'm about to demonstrate the use of an old style of collections. All right, there's no real value in typing out the code that I'm about to paste into our project. There's a newer style of collection that fixes some of the problems with the collections I'm about to demonstrate. I'm merely showing this as a thought process so you can see why you might still see some old code examples using these old style collections and what the problem is with them and why we have a newer version. So these old style collections have been available ever since the original version of .NET came out in 2002. In 2005, I think, they fixed some of those problems. We're currently on .NET version 5.0 or 5.1, I don't know, whatever version you're currently working with in your copy of Visual Studio. So what I'm saying is that you can merely just watch and follow along at this point. Don't bother typing all this in, all right? So what we're going to do is start off by just pasting in some code here to demonstrate one of the first collections that I want to feature. All right, so you can see that I created this system.collections.ArrayList, and I initialize it to a new instance of that class. Now, what is an array list? There are basically many different types of collections available to you in the .NET Framework class library, and each of those collections have a unique set of functionality. That's why you have so many of them. And this is a very simple collection. It mirrors to some extent what you can do in an array. It just adds on a few extra features. All right, so you can see here in line number 29 that I create a new instance of this system.collections.ArrayList. And then beginning in line number 30, 31, 32, I actually am adding each of the object instances we created here earlier into our array list. In line number 33, I'm removing one of the items. Let me comment that out, and I'll demonstrate why it exists in just a moment. Now, the real challenge happens in line number 35. If you actually take a look at the add method, you can see in IntelliSense that what you pass to the array list is of type system.object. Now, do you recall what was so special about the data type system.object? Well, it's the genesis of all of the classes in the .NET Framework class library. In fact, it's really the basis for all custom classes that you'll create when you build your own classes or your own applications in .NET. So you can basically put anything you want to inside of that array list collection, and it will accept it. So you can see that in these lines of code, in lines 30 and 31, I'm adding a car class instance. And then in line number 32, I'm adding a book class instance. Now, do you think that this is a good thing or a bad thing? Well, there are some downsides to allowing this. And the first downside is that since you are adding everything into the array list as system.object, once we go to retrieve the object out of the array list, the first thing we're going to have to do is perform some data conversion on that object so that we can get it back to its original data type so that we can do something meaningful with it. And you see that I've done that here in lines number 35 through 38. So take a look here. I'm using this for each syntax. I'm going to loop through and continue to loop through for every object inside of the array list. Each time I encounter a new object in the array list, I'm going to retrieve its reference into a variable called O. Now I want to print out something about the O object. I want to print out its make property. You can see make is a property of car. And so I'm just going to go ahead and print out make, right? Since we have cars in that collection, they should print out just fine. And so the first thing I do is, because at this point, O is just of type system.object. It's not of type car or book. It's just system.object. But I need to cast it to a car in order to get to the make property. So I use the car class in parentheses next to the letter O to perform a cast. It's like a temporary data conversion, all right? And then you can see I'm using the parentheses in this particular situation as an order of operations operator, all right? So just like in algebra, you would perform this operation first because it's inside a set of parentheses, and then you would perform this operation next, and then finally you have the method invocation operator, the use of the parentheses. It can be a little mind-boggling with all those parentheses, but that's just your way of first casting O to a car and then getting to the make property and then passing the make property to console.writeLine. Okay, complicated line of code, but this highlights one of the problems with this syntax. So will this actually work? Well, let's run the application. And after a moment, we hit our first speed bump here, and we get an exception that unable to cast object of type working with collections book to type working with collections.car. All right, so what's the problem here? Well, it all worked fine. I mean, you can see here that we were able to print out the make for car 1 and car 2, Oldsmobile and Geo, and then we came to book, and we tried to cast the object that was originally of type book to a car, and that's where we ran into the problem. Okay, it cannot be done. So we're dying, our program is crashing on this line of code because we're trying to take O, which was originally fundamentally a type book. We're trying to cast it to type car, and this is where the exception happens. Okay, so the reason this happens is because the array list, or more accurately, the original set of collections work with system type object, which is a form of working with loosely typed objects. And instead, we would prefer to work with strongly typed objects. What if, instead of working with a collection that worked with any type of object, and we can just throw the kitchen sink, anything we wanted to, in that array list, what if it only accepted car? So we try to put a book in, but we get a compilation error. It doesn't even allow us to compile the program, and it says you can't put a book inside of that collection. It is only going to accept typed cars. So we get a sense of a peace of mind whenever we're writing the application to ensure that it's only going to accept certain data types. All right, so that's a strongly typed application. What we have right now is a loosely typed application, which demonstrates problems at runtime. Okay, so now I've said a lot of bad things about this array list, or about the original collections in general. There's actually some great things about the array list. We can, for example, get to a lot of different things. Like take a look at the fact that I can remove either a single item or an item at a specific position, or a whole range of objects from the array. You couldn't do that with a regular array, but you can do that with an array list. So what if we use the remove method to actually remove that item from the array list? Will it work now? Let's run it. And you can see it works because we've added the object to the array, which was fine, and we removed it before we attempted to do that whole casting operation. Okay. And there are some other features as well with the array list. Let's just go down through a list. Oh yeah, you can see if the array list contains an object. Do you have this object? Yes, I do. Great. Then let's see what you got. What are the values inside of that object? You can get a count of the number of items, and yeah, there are things that as you look through this list you can do with regular arrays, but they're more full-featured here. So that's one of the first benefits of using collections over arrays. All right. So I think I've made my point. Belaboring the point now, let's move on to another type of array. Still one of the old style collections, I should say one of the old style of collections instead of arrays here. Mix some words up here. And we're going to paste in the use of dictionaries. Okay. So here you can see that I'm using a data type called list dictionary. It's in the system.collections.specialized namespace. And as you see here in the little text that I've added, dictionaries allow you to save a key along with the value, and it also supports some neat features. All right. This dictionary is called a list dictionary. It's named after a family of collections that all share the name dictionary at the end because they have both a key and an actual value that you want to store. It's kind of similar to the Webster's dictionary, where you have a word and then a definition that's associated with it. All right, the analogy ends there, but essentially with a dictionary style collection, you have a key. Maybe it's the last name of a customer or a customer's ID, and you can say, give me all the information you have associated with the customer whose last name is Tabor, and then it will retrieve back from memory the object that's associated with that last name, Tabor, or customer ID 1234. Okay? So the key portion of the dictionary allows you to easily look up the associated value in the dictionary. So here again, it has an add method, and this time add, first of all, allows you to give it the key, which in this case we're going to use the make of the car, and then the value, which will be the car object itself. So if I want to find the Oldsmobile, it would return back to me car1 object. Okay? Now notice it suffers from the same problem that we saw before. I can add any data type to the dictionary, and yes, the same challenges exist here that we just talked about a moment ago. The thing about using the dictionary is that it's easy to get to an element by just using its key. So in this case, look at the fact that I'm getting to the geo by using these square brackets and then passing in the name of the key. In this case, the make was the key, and I'm going to use the make geo. It returns back to me an object that I cast to car, and now that I've casted it to car, I can retrieve the model property. So in that regards, I don't have to use just an ordinal value. I can find the specific one I want by using the key. But as you can see here, the downside is I'm able to pass in the first name, and I'm going to retrieve back a book of type system.object. But when I try to cast that system.object to a car, it's going to say it's fundamentally a book. You can't do that, and I'll get another exception. So to prove that, let me just go ahead and run this. All right, and here we go again. It's a different type of error. Object reference is not set to an instance of object. However, the issue is the same. And so I said all of that to say this. If we could create a collection that was specific to either book or a collection that was specific to car, then we could only add instances of the correct type into the collection, and we could also treat all items in the collection as that given type, and we wouldn't have to cast objects upon retrieving them out of the collection. Now you might think, well, that's limiting. What if I want to put things in the collection? In programming, limiting is usually better, at least when it comes to working with data types, all right? So that's exactly what happened several years ago. This whole conversation about we wish things could be strongly typed. In C# 2.0, which came out in about 2005, Microsoft added a new set of collections that were based on the concept of generics. So the concept of generics itself is a bit advanced, but in a nutshell, a generic type provides a basic implementation of some functionality. In our case, collections. However, the user of a generic collection will make the collection specific by adding or telling it what data type it wants to use. So from that point on, it becomes a strongly typed collection to the type that you defined it to be. So you define the specific data type by defining it between angle brackets. And let's go ahead and give you an example of that. Now, you've seen these angle brackets before. I said, don't worry about them. I don't want to talk about generics just yet. But now is the time we talk about generics. So let me create a new example, and we'll create a list of type car called myList equals a new list of car. All right. So notice the nomenclature that I use. I call it a list of car, a list of data type car. List is a generic collection, and you can see in IntelliSense it calls it list of T. The capital T stands for the type. It is a generic collection until I make it specific by giving it the type. In this case, I give it a car. Now it's no longer generic. It's specific to type car. It can only hold cars, right? All right, great. Let's continue on. So my list add. Now notice IntelliSense this time, it's not allowing us to add any system.object. It's specific to adding cars, a car that the parameter name is item. All right, so the type car is the important part here. So car1, my list.add car2. What happens when I attempt to go mylist.add book1? And I give IntelliSense a moment to catch up. It gives me a red squiggly line. I hover over the squiggly line and it says the best overloaded method match for system.collections.generic list working with collections.car.add has some invalid arguments. All right, again, programmer speak, but essentially it's an invalid argument. Why? Because the data type is wrong. Okay, so let's go ahead and just comment that out. Now, look how cool this next part is. We'll do the for each again. This time I can rely on it being a car, so I'll do for each car in my list. Now, watch this. Console.writeLine car.model. All right, let's make sure it works before I start bragging about it. And it does. Cutlass Supreme and Prism. Awesome. All right, see how easy that was? There was no casting required in order to make this work. Why? Because we can count on the fact that everything in my list is of type car. Great. Now you might wonder where list comes from. It comes from system.collections.generic. Now why didn't I have to type out system.collections.generic? Where would I look if I were me, thinking that I'm able to use this object out of thin air? Where did it come from? Right. We look at the very top of the file and we can see that by default, Microsoft has added system.collections.generic to just about every project template because it's such a fundamental, vital object or namespace inside of the .NET framework. And therefore, they added it by default, so we didn't have to do that control period on our keyboard to add the using statement of the namespace. It just is there automatically. Great. All right, so let's do the same thing now with a dictionary style generic collection. The dictionary is a bit different because we'll have to supply it with two data types. The data type for the key and the data type for the value. So for example, let's do this. So I'm just going to create a dictionary, and then when I open up, notice with the angle bracket, it requires a type for the key, T key, and a type for the value, T value. All right, so just whenever you're in doubt, read the IntelliSense and then read any description. T key is the type of the key in the dictionary. So we'll make this a string because we'll make the make of the car as the key that allows us to retrieve the car itself, right? So after I add that type, making it from a generic collection to a specific collection that works with cars, then we'll give it the actual type that we're going to store, the T value, which you can see in IntelliSense as the type of the values in the dictionary. So this will be of type car. So we would say this as a dictionary of type string car, or a dictionary whose key is string and whose value is car, or something along those lines. All right, let me finish off this example. So we'll call this my dictionary equals new dictionary of string car, like so. Now, whenever I go to add, we're going to add car1.make as the key, and then car1 as the value. Same thing, my dictionary.add car2.make and car2 as the value. All right, and now let's just do let's read them out. So let's just get my dictionary, and how am I going to read this out? I'm going to use those square brackets again. That's how you access a value, whether it's an indexed value into a collection or array, or in this case we can give it a key value to get into the array, and then we'll give it the string geo, which should return back one item. And now notice again, no casting. I'm able to go directly into the property for car called model. And so now let's go ahead and run this just to make sure it works. It does. We gave it geo. It returned back to us the model called Prism. Awesome. So just to reinforce the idea of generics, what I want to do is actually go back to a previous lesson where we were talking about enumerations. Let me find that project, Understanding Enumerations. It'll open up a second copy of Visual Studio here. And I want to talk about this line of code, the try parse, and we passed in superhero. So we were essentially telling .NET to attempt to parse the input parameter user value into a superhero data type, which was an enum. So I'm sure try parse could have been implemented differently, but it's using generics, the generic syntax, to make it succinct and expressive. And so try to parse user value into a data type of superhero. Okay, what I want to do is move on to the next and final topic of this lesson. You might recall this initialization syntax whenever we were working with arrays. Let me comment all this out. So we did something like this, string names equal, and I think I used some creative names here, but I'll just go up Bob and Steve and Brian and Chuck, right? All right, so this saved us a few lines of code by both declaring and initializing the array in just one line of code. And at that time, I said that you'll see this pattern again when working with collections. Well, here we are. So as you look at examples out on the internet, out on MSDN, you're going to see the use of object initializers. So it lets you shorten about 3 or 4 lines of code, maybe more, into a single line of code like this. So here we go. Car1 equals new car. And now I can do this. Make equals Oldsmobile, model equals, start that over. All right, let me comment everything out here. Even the stuff at the very top that we started with. Okay, let's move back down to the bottom. We'll comment this out as well. All right, here we go. Car1 equals new car. And now make equals Oldsmobile, model equals, call this Supreme, car2 equals new car, make equals Geo, model equals Prism, and so car3 equals new car, make equals Nissan, model equals Altima. Great. All right, so notice as you were typing, or as I was typing, the IntelliSense displayed only the public properties for the car to help guide you. Furthermore, it only shows you properties that are not already set in the initializer. So let's do this one more time. So here we go. First of all, we see both make and model, and we'll start off with make equals. So first of all, it'll only show the public properties for car. If we had any other properties, like private properties or any methods, it wouldn't show up in IntelliSense because it wouldn't make sense in that context, right? So here again, we did Nissan. Now, when I hit the comma on my keyboard, it will show me all the rest of the available properties. Since we already set make, it wouldn't make any sense to show that property again. So it only shows me model this time, and I can type in Altima. Pretty cool. So the syntax is easy. After you create a new instance of the class, you use an opening and closing curly brace. Inside of the curly brace, you can then start setting properties in a property name equals value syntax format, and you separate each name value pair with a comma. And so this will work for any data type, not just strings. That's all I've shown here, but because to keep it simple, but you can use integers or even complex data types as well, which brings us to the next evolution in this idea, which is collection initializers. And this will kind of cook your noodle. So I'm going to just create an example and then we'll talk about it. All right, so here we go. Okay, so this syntax might look a little daunting at first, but you'll see it so often in code examples that I really want you to be aware of it. I recommend that you simplify it and you understand that you can use the same object initializer syntax by initializing entire new objects with the initializer syntax within the context of collections. So even though it looks like about 4 or 5 lines of code, that's really just one line of code. And once you wrap your head around initializers, object initializers, collection initializers are very easy. Now, I formatted this code by breaking it up into several lines, and that's how I would prefer to read it. But again, it's technically just one long statement. So after the initial declaration and the creation of our new instance of the list of type car, then there's an opening and closing curly brace, and then inside we create 3 new instances of car. So notice that this syntax precludes the creation of an identifier to hold each new instance, such as car 1, car 2, car 3, like I did at the beginning of this example, or just above it. We're only creating new instances in memory and then getting a reference and holding on to that reference using the variable name car 1, car 2, or car 3 here in lines 89 through 91. Now, in the collection initializer example below it, I'm creating new instances of car and then adding them to the collection immediately. So the collection will keep track of the reference to the position in memory that holds that new instance of the car class. So as long as something's holding on to it, that's all we care about. All right, so you should familiarize yourself with this syntax and use it from the start so that it just becomes part of your personal style. All right, so let's recap what we talked about in this lesson. In this lesson, we started off by looking at collections as a robust alternative to arrays. But as we started using the basic original collections that are available in system.collections namespace, we saw that they were not strongly typed, and therefore we discovered some downsides and some challenges. Then we said, what if we could create a collection that was specific to car or specific to book? And that was the impetus to creating generic collections, or rather a generic implementation of a collection that's made specific by the data type inside of the angle brackets that we use whenever we're creating a new instance of that given generic collection. So that's what a generic collection or generic method actually does. It allows you to define the specific data type that you want to use inside of that method or that collection. All right. So now we can work with collections in a strongly typed manner, and we saw how great of an improvement that was. We can catch any exceptions at compile time instead of at runtime when we've distributed the application to billions of users. Okay. Then we talked about object initializer syntax and extended it to the collection initializer syntax as just a shorthand, a way of creating instances of objects or instances of or properties inside of an object with a new instance of a generic collection. Okay. So that's about it. We're almost to the end. You're doing great. Let's keep pushing forward. We'll see you in the next lesson.